So I've got this diagram first of all to show us, just to kind of frame what we're going to talk about today. So this is a fairly traditional view of what continuous delivery looks like. We've got our source code over on the left. Each time we commit to source control, we're going to carry out some sort of builds and some automated tests in our build server. And today we're going to use TeamCity for that. If our tests go green, we're going to create a release artifact, a NuGet package, and pass that onto our release management system, which can then deploy that out to our end environments. This is the sort of process that people tend to follow in one way or another for the application. However, people don't tend to do that for the database, and that's what today's webinar is all about. Today we're going to focus on this middle bit here. We're going to take it as read that most people are already reasonably familiar with source control. We're going to assume that most people are already source controlling their database schema using either Visual Studio database projects that comes with the Microsoft Visual Studio, or that they're using the Redgate SQL source control product. So they're keeping their database scripts in source control, defining the state of the database. We're going to talk about how we can read from that source control, how we can automatically test that using TeamCity and Redgate, how we can create the packages and pass them off to our release management system. Today we're going to be using TFS for source control, TeamCity for our build server, and we have Octopus Deploy set up for release management. I'm not going to go into a huge amount of detail about how I've configured Octopus Deploy. I'm just going to mention that it's there, and I'm going to show you how I can pass packages off to it without going into a huge amount of detail into how I've configured it. If you are interested in how we've configured it, then I'm sure there'll be some documentation that we'll be sending around afterwards. So as I said, these are the prerequisites, the prerequisites for today's discussion. You're already source controlling your database using either Redgate SQL source control or Visual Studio database projects. You already have TeamCity installed. We're not going to go through the initial installation of TeamCity today. We're just going to go through the configuration of the database part of it. The Octopus Deploy bit at the end is a nice cherry on the cake. It's not a requirement, but if you are using Octopus Deploy, if you're familiar with it, or if you're familiar with the concept of a release management tool, we are going to touch on how it links up. And in order to follow these steps, you will need to install the Redgate SQL automation pack on your TeamCity build server. And I'm going to show you how we can use that. So these are the 7 steps. That have been bounded about on Twitter and emails and various other things. These are the 7 steps that we're going to go through. I'm not a big fan of slides, so I'm going to leave the slides now, and we're going to jump straight into playing with code and playing with the TeamCity GUI and so on. The first task is to install the plugins. I've actually been a bit cheeky. I've already done that. And the reason why I've already done that is because it does require that you restart the TeamCity server. And when we practiced this a few days ago, it turns out that on my machine that takes about 5 minutes to restart, and that made for a pretty boring 5 minutes of demonstration. So I'm not going to show you that bit, but I'm going to talk about how easy it is to do. So on your TeamCity server, there's a directory in TeamCity, which is the plugins directory. If you Google for TeamCity plugins and documentation, it's very easy to find. And all you need to do is place the plugins that we're going to be using today. We're going to be using the Redgate TeamCity plugin and the Octopus TeamCity plugin. All you need to do is place them in this plugins directory and restart your TeamCity server. And TeamCity will pick these up and unpack them and integrate them into the GUI of TeamCity. Just to show you where you get these from, you can download the Octopus one from the Octopus downloads page. It's just here. And the SQL automation pack you can download from the Redgate website. Just go ahead and download it from here. The SQL automation pack, you do need to run an installer, which does require a restart. and then once you've got it, you will open it up. You get this little intro to the SQL automation pack, which I'm just loading up now, which has all the bits and pieces you need. We actually released a new version of this about 15 minutes ago, which has an additional option up here, but the one that you're interested in is the TeamCity plugin, which at the moment is in the top right, but as I say, we released a new version 15 minutes ago, so I don't know whether it's still in the top right, but it'll be in this top section here. If you open up this folder, this is where you'll find that SQL CI TeamCity zip folder. So you want that TeamCity zip folder, the zip folder that you'll download from Octopus Deploy. You're going to go ahead and put them in the plugins directory in TeamCity, and you're going to restart your server. So those are the steps that I've already carried out ahead of this this webinar. Pretty simple steps. It takes only a couple of minutes, or however long it takes you to restart your TeamCity server, and that gets you up to where we are now. So that's step one. Step two is to create ourselves a new TeamCity project. And then after that, step three is to add a build configuration to that project. So let's go ahead and do that now. If you're familiar programming in TeamCity, then this will all be very, very familiar, which is great. So first of all, to add a new project, we need to go to the administration console, the administration tab even. And we go to create project on the top right. And we're going to give this project a name. For the sake of this demo, we're using the database that notionally sits behind the SimpleTalk website. So we're going to call it SimpleTalk database. And let's go ahead and save that. The next step was to add a build configuration. In here, we're going to add the name of our build configuration. So this is a build configuration for the database build part. So I'm going to call this SimpleTalk .build, because this is the part where I'm building my database. I'm going to create a package for it, and I'm going to carry out some tests on it. The rest of the defaults are perfectly fine. So already that's got us through the first few steps. Just going back to our 7 steps again. We've already installed the plugins, created the new TeamCity project, and we've added the Redgate build configuration to that project. The next thing we need to do is add our source control route. So this is where we're going to talk to where we have our source control scripts. Now I mentioned at the beginning that you needed to either be using Visual Studio Database projects or Redgate SQL source control in order to connect to this route. I'm using TFS. So this is my TFS server. I should have logged in before the demo. I'll just take a couple of minutes to twirl around. And this is where I've got my script saved. I'll show you quickly in Management Studio. I'm using the Redgate SQL Source Control plugin, and I'm connected to the default collection and this workspace within that collection. So while I'm waiting for that, I'm just going to select in the drop-down, I'm going to create a new version control route. So I need to put in the location of my source control. The type is, for me, Team Foundation Server, but this will vary depending on what you're using for source control. And in the options, just give it a root name that's easy to remember and use throughout your TeamCity configuration. We're going to give it the URL. So our URL is it's this much for me. If you're using TeamCity. And my username in this example and I need the root to my script. Just to show you how I set out my source control. I have my source control, I have the scripts folder directly the part, my workspace here is in a file called simple.database. So that's all I need to copy across because I'm using TFS. The rest of the options, the rest of the defaults are all perfectly fine. I'm just going to go ahead and test my connection because I do have butterfingers, and it'll be a miracle if I've managed to write my password right the first time. So just double check that that's actually connected. It is. I got my password correct. And we can go ahead and save that. So what we've done now is we've created a project with a build configuration for the build part of the step, for the build part of what we're going to do, which is reading the information from source control, building the database and creating a package. And we've configured my source controller so it knows where to look. The next thing on my 7 steps is to add the Redgate build step and the version control trigger. So let's go ahead and do that. So what I need to do now is, if I scroll down, go to the build step. This is the thing that we actually do. So when we set up our version control, we're just telling it where to look for our code. What we need to do now is add the thing that it's actually going to do. So this is where it gets really interesting. Now there are a whole bunch of default types of build steps that you get, such as MS build, command line, and Ant script. But because we've added the Octopus Deploy and Redgate TeamCity plugins, we've got a whole bunch of Redgate steps that we can follow. We've also got a whole bunch of Octopus Deploy steps that we can follow. So the first thing that we can do is do a couple of Redgate steps to build our code and test our code that we've got in source control. At this stage, I should probably describe in a little bit more detail what we're doing here. So the first thing that we're always going to do every time we commit to source control, or whatever frequency you choose, is to add a Redgate SQL CI build step. What this is going to do is it's going to take your code from source control. It's going to check to see if there are any syntax errors, because what it's going to do is it's going to try and build the database from those scripts. If there are any syntax errors, it's going to fail. It's also going to check for any invalid references. If you have any dependencies that are broken on your database, let's say you've added a table, added a view that depends on the table, and then renamed the table, for example, that would cause your database not to build correctly. Which would be bad. At that point, you've got some code in source control which is broken, and it should be your first priority to make sure that the code you've got in source control at least builds. After you've got code that builds, we create a package. So once we've tested that it builds correctly, we create a package for that, and that's a NuGet package, which effectively is a fancy zip file with a bunch of metadata attached to it, including the build number and so on. And we can use that package in a consistent way to later on in our pipeline, we can carry out unit tests on that package. We can deploy that package to another environment using SQL CI Sync, or we can use it with Octopus Deploy later on in our pipeline. But the idea is now that we're working off a consistent release artifact, a consistent package that we can deploy to each environment. So let's go ahead and configure the SQL CI build step. It's a really simple set of options that we have here. We can give it a step name, that's optional. I'm happy with the default Redgate SQL CI build. We need to say where our, oops, I won't scroll around so quick. We need to say where our source control root is. Sorry, where our scripts folder is within source control. If we've checked out a directory with a whole load of subdirectories and our source code is actually a subdirectory, we need to provide the relative path from the root that we checked out to the path where we'll find our scripts. In my case, I've just checked out my scripts file, so I don't need to worry about that. We're also going to add a package, package ID. So this is what we're going to call the NuGet package that we create. So I'm going to call it simpletalk.jetbrains. Now, one of the really nice features of TeamCity, and one of the reasons we like plugging into it, is it's got a NuGet repository built in as standard. So when we create these packages, we're going to save them straight to the NuGet feed that's included within TeamCity as standard. So you do need to enable it if you haven't enabled it already. What we're also going to do is we're going to inherit the build number directly from TeamCity, which means we'll handle all the version numbering for you. So we'll create a package called simpletalk.jetbrains version 1, simpletalk.jetbrains version 2, simpletalk.jetbrains version 3. Each time this configuration builds, which is really nice because it means you don't need to worry about versioning. The versioning is all handled by TeamCity, and your packages will all have the correct version. The other thing we need to do is we need to think about where we're going to build the database. In the same way as if we're compiling code in C#, what we need to do here is we need to take the scripts, we need to use the Redgate SQL Compare engine to build our database from scratch on a SQL server somewhere. So in order to do that, we need to select one of two options. Either we provide credentials for a SQL server with enough, we provide the details of the SQL server we can use with enough credentials to build the database from scratch. I would tell you which credentials those are, but SQL Server credentials are really quite complicated, and so it depends a lot on your database. Or we can just go ahead and select local DB, which means a hell of a lot less configuration. It's a lot simpler. We do also have the option down here. This is optional to carry out our builds on a persistent database. We do know that there are some organizations in the financial services, for example, that are very highly regulated and where they're not allowed to create databases over and over and over again. So what you can do is you can carry out your build on a persistent database, and what we'll do there, if you build a database once, we'll just use that database to build your schema and then truncate and then delete all the objects again. So effectively, we can do our builds on a single database, which gets around a lot of compliance issues if you do happen to work in a highly regulated environment. For most people, however, just selecting the local DB option should be fine, and that's all we need to do. So all I've actually done here is I've selected the default option here, I've given my package name, and I've said I want to run it on local DB. That's all the configuration there is, and I'm going to go ahead and save that. And that's the first part done. What we're going to do here is, first of all, we need to set up a build trigger. So that's relatively simple. I just go to build triggers, add a trigger. I'm going to trigger a VCS trigger, so every time I commit to source control. And that's it. So if I go back to my projects, we should see now that we have a project here. We've not built anything on it yet, but we can go ahead and change that simply by going into make a change to our database. So I'm just going to demo that by making a change using the Redgate SQL source control tool. So I'm just going to go find a stored procedure to play with. This one will do. Just going to go ahead and carry out a change. Just going to go ahead and make a quick change. I do apologise, by the way, for some of the performance of Management Studio and TeamCity and everything. I'm actually running SQL Server, TeamCity, all the Redgate tools, TFS, a full TFS server, on a little virtual machine on an old laptop here. So I'm doing quite a lot on here. So let's go ahead and press Tab to expand that out using Redgate SQL prompt and execute that change. And we're going to go to SQL source control, commit changes, and all I need to do is write a comment. So my commit message is expanded a star. I'm sure you can all think of far better commit messages for the sake of brevity. I'm just going to go ahead and just write a short message for the time being. Just going to go ahead and refresh the list of changes on my database. What we can see, by the way, on the left-hand side, our database is linked to source control because it's green. We can see what all the changes are. I'm not going to go through a full SQL source control demo at this point because, as I said, we're taking it as read that you're already doing version control of some sort. So we're going to go ahead and here's our change. I'm just going to go ahead and commit this into TFS. We should see that change in a moment pop up in TFS. If we just go to stored procedures, and has it finished yet? Not quite. That'll finish in a couple of moments once commit is finished. Once it's finished, it will show up in TFS, and then it will trigger a build in TeamCity. What I'm going to do now is I'm going to pause for a few questions. I think there have been some questions that have already been asked, so Becky is going to field a few of those and I'll answer them. We can see how the build is triggered. So while this build runs, I'm going to answer a few questions. Becky, what questions do we have?
Thanks, Alex. So I think if we just start at the top, so Dan had a question from your very first steps about whether this is relevant for Oracle deployments as well.
That's a very good question. So we do have, Redgate does have a bunch of tools for Oracle, continuous integration with Oracle databases. I'll just go to the website here, Redgate Oracle TeamCity, I think that might find it. We don't have a plugin that is quite as easy to use. Having said that, you can use the command line versions of the deployment suite for Oracle, which also comes in the Redgate SQL automation pack. And you can script out your deployment process, your continuous integration deployment process using that. We have documentation here, including a tutorial using TeamCity or Jenkins. But since this is a JetBrains demonstration, I'm going to focus on the TeamCity part. So we do have full documentation here. I'm going to post this link into the chat window, so anybody who is interested in continuous integration with Oracle can go ahead to that link and you should find all the documentation you need there. Today's demonstration, I am going to be talking about SQL Server and the plugin that we have for that.
Cool. From Eric, do these plugins handle SSC migrations?
SQL's, by that, can I just double check? Do you mean Redgate SQL source control migration? It's a feature of SQL source control which allows you to handcraft a specific script to use during deployment.
Yes, it says yes, the non-beta migrations.
Okay, so it doesn't support migrations version 1, the non-beta type. It does support migrations version 2. So I'm sorry to let you know that migrations version 1 is not supported in this process, but migrations version 2 is. We hope to have that out of beta in a few months' time, but I can't be more specific than that, I'm afraid.
Great, thank you. And our next one is from Ed. He says, what do you build? Is it an SSDT DAC? Sorry.
Good question. So what we build, I probably should have shown you that and made that more obvious. We're still in the process of building it at the moment, so I can't show you one here. But once this is finished, I'll show you. We're building a NuGet package. There we are, right on cue. So this is the NuGet package that we created, simpletalk.jetbrains.0.1. Within this NuGet package, we have a script for the state of the database at the current point in time. And this contains all of our scripts from source control. So this is very similar to a DAC pack that is used in Visual Studio database projects. A couple of notable differences. With SQL source control and with NuGet packages, we're able to save scripts of static data. I don't believe that's possible with a DAC pack. However, actually a lot of the time deploying the data is really important when you're deploying a database. So it's a good idea to kind of treat that as a first-class object, and SQL source control's got some nice functionality for that, and we inherit that functionality from SQL source control. Using NuGet is also a nice idea because a lot of other release management tools such as Octopus Deploy and I believe release management for Visual Studio and definitely Bamboo, Atlassian's Bamboo, the deployment functionality within that. They all tend to understand NuGet packages. NuGet was actually a technology designed by Microsoft to handle updates for Visual Studio plugins. So it's an ideal technology really designed by Microsoft. It's really very simple. It's basically just a zip file to the extent that you can just rename the file extension and extract it exactly like a zip file and it works. And they make handy little packages that define kind of a model of the state of the database at a point in time. And then we can read those with our SQL compare technology to allow us to generate upgrade and downgrade scripts.
Cool, thank you, Alex. So a couple more. This is just one from Roland about SQL CI, about a bug ticket in SQL CI. I don't know if you know about this or if we could pass that back to the team.
That particular bug ticket, I'm afraid I don't have them all committed to memory. So what we'll do, Becky, can you make a note of that and we can follow up by email afterwards? I'm not sure if we're going to be able to look that up during the webinar. Sorry about that.
And then one from Michael about PostgreSQL.
Yeah, I'm afraid we don't support Postgres, sorry. What we're looking at today is purely SQL Server. We do also have a story for Oracle, which I mentioned earlier with the link in the chat window. But this is pretty much for SQL Server.
Great, that's it for now, but this is brilliant. Do keep asking your questions as we go and we'll keep pausing to answer them.
So what we're going to do now is we're going to talk a little bit about what we can do with our NuGet packages. So there are a couple of Redgate build steps. So if I was to go and take a look at the project here, we go to add further build steps. So I'm going to go to edit the configuration settings and build steps, add build step. I mentioned we always run build first because that's the thing that creates our NuGet package for us. And it's the NuGet package that is treated as the source for all of our other tasks. I mentioned a little bit about unit testing at the beginning. That's one of the purposes of a continuous integration server. It's not only to build your code, make sure it compiles correctly, but also make sure you've got some sort of release artifact that you can use moving forward. It's also important to write some tests. It's one thing to say it builds, but it's another thing to say it does what you expect it to do. If you're using the T-SQL-T unit test framework or the Redgate SQL test plugin for Management Studio, which looks a bit like this, it allows you to write and run unit tests using T-SQL code rather than having to write C# as most unit test frameworks do for SQL Server. I'm not going to go into SQL tests in a huge amount of detail right now, but I just want to show you that it's there. So you can write and run your unit tests in Management Studio using SQL code. It's not that hard to do. You can commit these tests into source control, and then once they're in source control, you can automate the running of those tests on your CI server so that you know that every single time you commit to source control, your tests are running. This is valuable for the developer as they're doing their work. It is especially valuable for the developer if somebody 3 years before you was doing it, or to the developer after you leave the company in 3 years' time when they break your code and can't remember why. We also have the SQL CI sync step, and what this is going to do is what we think of an incremental build. Where the CI build does a complete build, it builds a database from scratch. Probably the entirety of the audience is screaming at this point because they're saying that you cannot build a database from scratch and just throw the old one away and build a new one and expect that to be a good test, because when we're updating databases, we have to think about data persistence. We have to think about the fact that the data still lives on. We can't just throw away the database and build it again. So what the SQL CI sync step does is it's going to take the package, and it's going to use a SQL compare engine. It's going to look at the code that's contained within the package and a target database, and it's going to carry out an update. And this should keep all of your data intact. You can use this partly as a way of just testing whether you can manage a deployment using this process that we're putting together. You can also use it to keep a bunch of testing environments up to date every time you commit to source control. For example, you might want to have a development environment that developers use that's always up to date. Maybe you've got an environment that is always up to date for your application. Maybe every single build of your application is automatically deployed out to some environment. Well, this allows you to do the same for your database so that you don't get the database and the application out of sync. You can run sync and test in any combination as many times as you like. So for example, some people like to keep multiple testing environments up to date that are used for various purposes. Some people like to run various different sets of tests. They might run a single test or a class of tests or a full suite of tests, because some tests might be appropriate to run every commit because they don't take very long. Some tests might take 8 hours to run. Also within the test step, there's functionality to add test data in there as well. So you can generate a whole bunch of random test data before you go ahead and run your tests. So you might have a suite of load tests that you run overnight because they take 8 hours, for example, but a set of fast running tests that you run every commit. And you might want to run those on different server configurations or different editions of SQL Server or something to make sure it works on 2008 and 2012 and 2014, for example. Today, however, we're not going to go into a huge amount of detail. We're not going to set those up. What we're going to do instead is we're going to talk to Octopus Deploy. Octopus Deploy is a release management tool, and basically it's a tool for scripting out our deployment to each of our more senior environments. Whereas continuous integration servers are really good at testing parts of code in isolation and keeping individual environments up to date as soon as you commit to source control. Once you get to a reasonably complex setup, using a release management tool for handling your deployments out to your testing, staging, production, various different environments is a fairly good idea. As I said, I'm not going to go into a huge amount of detail about the configuration of Octopus Deploy in this demonstration. That's kind of a whole other demo in its own right. But what I'm going to do is I'm going to show you how we can hand off the NuGet package that we've created to Octopus Deploy, and how we can ask Octopus Deploy to deploy it for us. So in this example, my task is going to be to use Octopus Deploy to keep an environment up to date. And then I can use Octopus Deploy later on to promote my changes throughout my various environments. So going back to my 7 steps document, we've completed as far as step 5. What we need to do now is, go back. I need to add the Octopus build configuration to the project, and I need to add an Octopus build step to that configuration. So let's go ahead and do that. I'm going to go back to my projects. I'm going to go to the simpletalk.database project. I'm going to go to edit project settings. And I'm going to go ahead and create a build configuration. This one I'm going to call simpletalk.deploy. And the rest of the defaults are all acceptable. I'm not going to bother adding a new route because I can use the one I had before. I'm going to add a build runner. So I'm going to add the Octopus Deploy create release build runner. There are a few different Octopus Deploy things that you can do from TeamCity. What we're going to do here is create a release. Now, a release can be a collection of packages. It may just be one package, or it may be more packages. The reason being that Octopus is about deploying your whole stack. So you might have lots of different parts of the application. Maybe you've got a couple of web services, a website, and maybe a couple of databases behind it, or whatever combination of components that you want. The idea is that each component individually will be packaged up into a package, and then you'll tie a whole load of packages together into a release, because you might have version 17 of the application and version 21 of the database. So we're going to have separate packages for each, and we're going to have a release where we specify which packages we're using. By default, we're just going to create a release using the most recent packages. My Octopus URL is already included. I do need to go into Octopus and create myself a new API key. So to do that, I'm just going to go to my profile, API keys, new API key, purpose, TeamCity, generate new. So this is just for security purposes. In order to make a deployment, Octopus Deploy needs to know who you are and that you have the credentials to make that deployment. So it's already, so I'm going to go ahead and paste my API key in there. I'm just going to double check it has got my Octopus URL correct. Yeah, it does, localhost 83. I need to enter the project. So if we come back to Octopus Deploy, you can see my project is called simpletalk.jetbrains. So I'm going to call it simpletalk.jetbrains. The release number, what I'm going to do here is I'm going to reference the TeamCity build number variable. So the release in Octopus Deploy is going to have a number that's directly tied to the build number in Octopus Deploy. I don't want to just create the release, I also want to deploy it to an environment that I always want to keep up to date. So I need to deploy it to the latest environment. I do want to show the deployment progress. What that's going to do is that's going to give me the logs of Octopus Deploy as it goes through the process of deploying to latest. It's going to expose those within my TeamCity logs, and it's also going to report back to TeamCity whether or not the deployment passed. If I didn't tick this button, TeamCity would say I've successfully told Octopus Deploy to run the deployment, but it wouldn't tell me whether that deployment had worked. Whereas by ticking this button, it not only tells me the progress in the logs, but it also will fail the TeamCity build if the Octopus Deploy deployment fails. And I want to do that in this example. I'm going to go ahead and save that. So I've created my build configuration and I've created my build step. One final thing that I need to do is I need to add a snapshot dependency to the other to the database build configuration. I'm not going to talk about snapshot dependencies in a huge amount of detail here, but what I will say is it's a really amazing feature of TeamCity. It's a feature that doesn't exist in all CI systems, and it really makes more complicated CI workflows much more reliable and useful. I do believe that the previous webinar that JetBrains did was all about snapshot dependencies. So if you're using TeamCity, if you have complex build configurations that all depend on each other, and you're not using snapshot dependencies, I really would urge you to go ahead and look at the last webinar in this series all about snapshot dependencies. What I also want to do is add a build trigger. So with this build trigger, what I actually want to do is I want to trigger this one not from a version control trigger, but I want to do it from a finished build trigger. So every time the database build is completed, and I'm going to say only after it's successful build, because if I fail the database build, I don't really want to try and deploy that package. I only want to deploy the packages that pass the build phase. I'm going to go ahead and deploy that. So that's my trigger done. And now, if I was to go ahead and make a change, I'm not going to go back to source control and make the change all over again, because I think you get the idea. I'm just going to go ahead and click the Run Now button, which is really useful when you're setting things up. What this is going to do over the course of the next few minutes is it's going to build my database package. It's going to build my database from scratch, like we did before on LocalDB. It's going to check that my code works. It's then going to create a new NuGet package for me. So I can talk about that NuGet package as being good or bad. If the package is bad, then I'll go ahead and build a new package. I'll correct my change, go ahead and build a new package. This defends us from people fixing issues in flight. I don't know if you've ever had the issue where a tester has found a bug on some QA database and they fixed it in QA, and then they've just deployed that change to production. And then in production, the DBAs put a new index on a table because that doesn't count as a change, right? And then you end up with a version in production that doesn't accurately reflect what the developers have got to work with. And you end up getting into all sorts of complicated mess. So what this is trying to enforce is that development, the output of your source control should be a build package. Those packages are good or they're bad. If they're good and they pass all your tests, you can put that in production. If it's bad, then you don't fix the database in flight. You actually go back to source control and build a new package, and you put that into production when it's passed all the tests. So this is going ahead and building the database and building our package for it. And then this step here is going to ask Octopus Deploy, which Octopus Deploy is looking at the NuGet feed within TeamCity, by the way, so it knows where to look. It's just going to say, come grab the package from TeamCity and deploy it out to my more senior environments. So I've got a few minutes to wait while this goes through. That brings me more or less to the end of the technical part of the demonstration that I was planning on showing today. But we've probably got a few more questions. So we've got another 15 minutes or so to answer any questions that people have, and we can go on and maybe talk about whatever it is that you need to know.
Cool, thank you, Alex. So first question is around SQL CI. And this says, would you recommend using the SQL CI sync to deploy to production database? Or would you not?
So lots of people do. I know people that do. It depends a bit on how much confidence you have in the tool. It depends a bit on the sort of changes that you're making. SQL CI sync is going to fall foul of the typical sort of database diff tool problems where you're adding a new null column or renaming a table or a column, where you can end up having data loss or failed deployments. That said, migration to V2 does solve some of those problems. It's still in beta, so I don't really want to recommend a tool that's still in beta because I feel like that's unprofessional. But when it is ready, or if you're happy to use a beta tool, then that should solve some of those problems, because it means that you can write your own little bit of code to wrap around the deficiencies in release in database diff tooling. Beyond that, though, what a DBA tends to want before they deploy to production is they tend to want to know about the script. They want to know the script that's going to be run in production. They want to know that it's successfully been deployed somewhere else, and they want a summary of the changes. And I don't know if anybody that's watching has heard the news about the new the investment that Redgate has made in Octopus Deploy. We're actually building a new plugin at the moment that's going to allow you to do that. We've got some sort of build error here, so I'll troubleshoot that one in a minute. I've probably made a silly configuration error. But just while we're waiting for that, I can't actually show you that until I've made a deployment. But one of the things that Octopus Deploy does that's quite nice is it also exposes artifacts. So when you try to make a deployment, it will save an artifact for that deployment, and we can save, for example, the script. You can see a history of whether it's successfully deployed to other environments. And what Octopus Deploy also allows you to do is have an approval gate. So, for example, a senior developer or somebody, pick a job role at your company, can click the button in Octopus Deploy to deploy to production. But actually, what's then going to happen is there's going to be a breakpoint in that deployment, and an email is going to be triggered off to your DBA or whoever your gatekeeper is on your production database in order to say, here's the artifact, here's a script that somebody expects to run, this is the change that it's going to make, it's successfully run in all of these previous environments. It's then up to your DBA whether they want to approve that change, whether they're happy that it's been thoroughly tested or not. And at the point where they do that, we're not actually going to use a diff tool anymore when we deploy to production. What we're going to do is we're going to check that production is in the state that we think it's in, and if it is, we're going to execute that specific script. And that is normally, in most scenarios, the level of reassurance that a DBA wants, or somebody who's responsible for making a production database deployment wants. So what we hope is that the plugin that we're building for Octopus Deploy in the next, we're already building it, we've got a beta at the moment, and we hope to have it released in a few months. What we hope is that that's going to be a production-ready deployment tool that can be incorporated into Octopus Deploy for even the most scrutinized SQL Server database.
Great. So yeah, as Alex said, that's SQL release, and that's coming very soon. We're actually releasing the beta of that next week. So keep an eye out for it if you'd like to have a go and try it out. We'd love to know people's feedback. So a few further questions, a couple of which have been answered by Pavel, and then Eric asks, how is this handling three-part, four-part naming?
So you're talking about where you're specifically hard coding the database name in the name of your objects, or am I misinterpreting that? I have seen the issue recently where somebody has tried to have written their stored procedures with hard-coded database names, and that's caused problems when they've tried to deploy that database out, and that is a problem. You shouldn't do that if that's what you're doing. Having said that, I'm not entirely sure if that's what the question you're asking is.
Okay, well, we'll move on, but Eric, if you want to add some more comments, then do that in the question panel and we'll get back to you in a second. A different Eric is asking, is there an artifact exposed in the build pipeline that shows the actual scripts run against the server?
You can do that. So by default, there isn't, but it's very easy to do. I could go and troubleshoot this live in the demo, but I've got some sort of connection error. I've got an Octopus Deploy error code, some sort of HTTP connection, so I'm not quite sure what the problem is there. I'm not going to try and troubleshoot that now because it'll probably be quite boring watching me troubleshoot an issue, but one of the nice things about build servers and release management tools is they do give you really good feedback when something goes wrong, and it's saved in the logs. The question was that I was about to answer was, do we give you the build script? If I go to the configuration settings, and if I was to go to build steps, add build step, add SQL CI sync, in pretty much all of our build steps, there's an additional parameters box here. And what you can do is you can call the additional SQL compare options to save the script, either as an artifact or to a location on disk. And so you can build up a list of all the changed scripts. So you could execute them one by one if that's the sort of deployment process that you wanted to go through. Or just if you want to keep a record of the script that's been executed on that database. So you can do that within TeamCity. You can also do that within Octopus Deploy. What Octopus Deploy, I'm not going to go into a huge amount of detail. I've actually blogged about exactly how I configured it on my blog, which Becky may have alluded to earlier on, that I might plug this at some point during the demonstration. It's on the previous page now. Older posts. Deploying Redgate database packages with Octopus Deploy. This is how I've configured it for the demo. And all we're doing is basically using a little bit of PowerShell to execute the SQL CI sync command. The plugin that you see in TeamCity is actually a fancy GUI built on top of an executable called SQL CI. It comes in the SQL Automation Pack. So if I just fire up the SQL Automation Pack, I'll show you. SQL CI is the main command line tool that we're using to carry out all of these tasks, and it comes in the SQL Automation Pack here. It's just a dependency installer. You've got that, so you install it, and then you get the executable and all of the dependencies. So we're just calling that same command line that the TeamCity plugin is calling. We're just writing a little bit of PowerShell to do that, and I've exposed PowerShell for you here. There's nothing to stop you. You can see here that I've actually added a couple of options here already. And there's nothing to stop you adding an extra additional compare arg to go ahead and save the script out to a particular location on disk, so that you keep a record of all of those scripts. As I say, that's how SQL CI works, but we are working on a new plugin for Octopus Deploy called SQL Release, and SQL Release is specifically designed around exposing those scripts. The difference between SQL CI and SQL Release is that SQL CI is really designed for just keeping a database up to date, the general tasks that we want to do to test a database, in not particularly critical environments, so an environment that is disposable. SQL Release is going to be designed around creating upgrade scripts and saving those upgrade scripts, because that's a process that people are more familiar with once you get to more senior environments. But as I say, the functionality is there even within SQL CI.
Great. So we've got a couple more questions, but just before we switch to those, because I'm aware we're coming to the end of the hour, we have just got a offer for everyone that's attended the webinar, just as a little thank you for attending and hearing about our tools. And also just a reminder that the tools that Alex has demoed from Redgate are all available as a free trial from our website, which is redgate.com. So do just check those out if you want to try them out and get a free trial. And then finally, as I say, what we're offering for people who've attended the webinar, and this will go out on the email as well, is a free consultation time with Alex or one of his colleagues to talk about the themes that we've discussed in the webinar and how they might work in your environment. So it's just a chance for you and your team to actually talk through implementing some of these steps in your own environment, because we know it can be a a bit of a challenge sometimes to convince people across the organisation that these things really are worth doing. So get in touch, and either via Alex's email, which is alex.yates@redgate.com, or dlm@redgate.com, and we'd love to get in touch with you.
All of those emails will be in the email follow-up that goes out after this meeting, won't they?
Yeah, they will. So just a couple more questions, and then we'll wrap up. So thanks everyone for being here. It's been really, really fun for us, and we hope you've enjoyed it too. So Alex, just a couple more questions. So Eric has come back to me. He says for the 3 or 4 part naming, that's more or less correct for cross-database or linked server references, etc.
I see. So references to other databases get complicated because all we're doing within the Redgate tooling is looking at each database effectively as an island individually. So if you can build the database that references another database independently, then it will work fine. If you have a dependency, if there are scenarios in which dependencies can get complicated when you've got linked database servers and so on. It's a bit complicated to explain which scenarios do work and which don't, but basically, if you can build your database independently, it will work fine. If you cannot build your database independently, you'll have problems.
Cool. And then a final question from Simon. So this is about configuring the deployment chain. How do you do it to use 100% migration scripts versus SQL compare? It says, i.e. a script for every single change.
So SQL release will more or less do that. SQL CI, so all of the scripts that we're generating are based, we're generating our upgrade scripts at the CI stage. And so we will be using SQL compare to generate those scripts. If you want to handcraft every single script, you're welcome to go ahead. We tend to, our view at Redgate is that writing both the code to define how your database looks and also the code to define how to upgrade your database is first of all duplication of effort, and also means if you're writing twice as much code, you're also going to write twice as many bugs. And the experience that we've had when we've talked to customers is when they've scripted out every single change as a handcrafted every single update. You get into really complicated problems when you branch and merge, or when you try and apply update scripts when you've had what we think of as database drift on production, where maybe somebody's made a hotfix on production and then and so your upgrade scripts can only really be reliable if you know the exact start state and the exact end state. So we don't tend to promote that model where developers write all of their own upgrade scripts. The migration scripts functionality that we put into SQL source control is intended for those edge case scenarios where the generated script doesn't work. But our view is that when in the 99% of scenarios where the generated script does work fine, we would expect people just to use that because it's more. It means they can spend less time writing code, and they tend to write less bugs because most of the time, for just changes in stored procedures, SQL compare is going to be more reliable than a human.
Excellent. And then we'll have one final question from Jeff, and he asks, are CLRs included in the build?
CLRs. I believe, and I'm not 100% on this, so I'll try and follow up on email. Becky, if you can get me Ed's email address. I will double check on this. If you're using SQL source control to version your project, yes. If you're using SQL Server database projects, it creates the folder structure in a slightly different format. and SQL CLR objects aren't supported when we're using that format. So if you're creating, basically, if you're using Visual Studio database projects, no. If you're using Redgate SQL Source Control, yes. I believe is the answer to that. It's because in order for us to support Visual Studio database projects, we need to understand a completely different file format to what the tool was initially written for. And in our support of that, we don't support CLR objects.
Great. Thank you very much. Well, that seems to have answered everyone's questions. Simon's just got a final question for offline, but I'll send him your email address. So thank you, everyone. Hope you've enjoyed the webinar. And as we say, go and have a look at our tools and TeamCity and Octopus if you'd like to try implementing some of these steps for yourselves. Thanks, everyone. Have a good day.
Thank you very much for coming along, everyone.